In this video, I'm going to go over two examples of the counterexample method that we had in class. We're going to do a propositional logic argument, a deductive argument, propositional logic, where the underlying structure is the relationship between the truth values of simple statements. And then we're going to do a counterexample in categorical logic, a deductive argument where the underlying logical structure is the relationship between classes and categories. I want to note each of those types of arguments as we're going through so that we're clear what type of content we are going to be inserting into our new substitution instance to create our counterexample. Now, remember, our whole point in creating counterexamples is to take arguments where the content may or may not make the underlying logical deficiencies of the argument manifest, and extracting that logical form, and you're always going to want to show that on your exams and homeworks, and then introducing a substitution instance, putting in new content, maintaining the same underlying logical structure, where that content makes the logical deficiencies of the argument manifest. That is, the premises are clearly and obviously true, and the conclusion is clearly and obviously false. So when we get an argument like this, we want to read it through, look it over, identify the premises and the conclusion. So in this argument, we have, if Elizabeth grew up in the U.S., then she learned English. Elizabeth did not grow up in the U.S., therefore Elizabeth did not learn English. Step one is to put the argument into standard form. So you might want to pause the video and go ahead and try and do this on your own. Then start the video up again and compare what you did to what I did. Okay, so when we look at this argument, we have a conclusion indicator here. Therefore, so this is probably going to be our conclusion. That means that these two are going to be our premises. And everything looks to be in relatively good shape. This is the denial of an antecedent of our conditional. This is the denial of the consequent of our conditional. The only thing that we might want to do here is replace she with Elizabeth so that the phraseology is exactly the same throughout the argument, so that it's easier for our consumer to identify that this is the denial of the consequent in our final form here. So that's what I did. Now we've got our premises first, our conclusion last. All of our phraseology is the same, and we can identify this as a propositional logic argument, an argument that relates the truth values of simple statements to each other. Our next step then is to highlight the logical form words. Now, you might again want to pause the video, see if you can identify those logical form words, then start the video again and see how you did compared to what I did. Okay, so for propositional logic arguments, our logical form words are if, then, and, either or, and not. So when we look at this argument, we see the first sentence is a conditional, so we've got if, then, and then the second premise there is the denial of the antecedent, the first part of that conditional, and so we're going to highlight not, and then the conclusion is the denial of the consequent of that conditional, so we're going to highlight not again, and that gives us this. Now that we've got the logical form words highlighted, we want to keep those logical form words, and we want to replace our content words or phrases with capitalized letters in each place that they occur in our argument. So again, you might want to stop the video, see if you can do that, start the video again, and see how your answer compared to mine. Okay, so this is what I got. I got if G, then E, not G, therefore not E. Now that I've got my logical form, right, I'm in a position to substitute in new content that maintains that same underlying logical structure, but that makes the failure of the argument and a logical form level manifest through its content. So I'm going to create a substitution instance by substituting in new content. since this is a propositional logic argument, I'm going to be substituting in propositions or simple statements. So you might want to stop the video, see if you can come up with your own substitution instance, and then start the video and see how you did compared to me. So here's the substitution instance I came up with. If lizards are mammals, then lizards are animals. Notice that the antecedent of my conditional, that's false, but the relationship of the conditional is true. If lizards were mammals, then they would be animals. So the conditional itself is true. Now it's important that I have that antecedent being false because my second premise is the denial of that antecedent, and it has to be true as well. So lizards are not mammals. So now I have two true premises, and then I get my denial of the consequent, which is lizards are not animals, and that is clearly false. So now I've got a version of the argument, a substitution instance that makes it manifest that it's possible for the premises to be true and the conclusion to be false, and therefore all versions of that argument are going to be invalid arguments. Let's try another example. Here we've got an argument, no dogs or cats. Some cats are not pets, given that some pets are not canines. So the first thing we're going to want to do again is put the argument into standard form. You may want to stop the video, see if you can put the argument into standard form, then start the video and see if you got the same sort of answer that I did. Okay, so when I'm trying to put this argument into the standard form, I want to identify the premises and the conclusion. Here I've got a conclusion indicator. So I've got this as my probable conclusion. I've got a premise indicator here. So this is one of my premises. And the first sentence here, that'll probably be the other premise. So I'll put the argument into standard form. Each premise is a separate declarative sentence. The conclusion is a separate declarative sentence. The premises are first. The conclusion is last. I want to make sure that I use the same phrases or sentences for my content elements each time they occur. And in this case, I've got canines and I've got dogs. So I want to make that consistent as well. And that'll give me something like this. No dogs or cats. Some pets are not dogs. Therefore, some cats are not pets. Now that I've got the argument into standard form, the next thing I want to do is highlight the logical form words. Now, this is a categorical logic argument, so I want to use the categorical logic form words. I want to highlight those. Again, you may want to stop the video, see if you can do this yourself, then start the video and see how what you did compares to what I did. Our common categorical logic form words are all, no, some, are, and are not. So we've got no are, some are not, and some are not again. That gives us this. Now that we've got our logical form words highlighted, we want to then replace the content words or phrases with capitalized letters. So you might want to stop the video, see if you can do that, start the video, and compare your answer to mine. Okay, this is a categorical logic argument. So each of our content words or phrases are going to be names of classes or categories. So we've got dogs, cats, and pets. We'll want to substitute in a capitalized letter for each instance of dogs, each instance of cats, and each instance of pets. And that gives us the following. Now that we've got our logical form, we want to create a substitution instance. We want to put in new content that makes the defect of the underlying logical structure manifest plain through the content. So we do that by substituting in new content. In this case, new names of classes that makes the premises clearly and obviously true and the conclusion clearly and obviously false. So again, you're going to want to maybe stop the video, try to come up with your own counterexample, start the video, and see how what you did compares to what I did. Okay, so I want to substitute in new content to make my premises clearly and obviously true, my conclusion clearly and obviously false. So here's what I got. No, cows are reptiles. So substituting in cows for D every time it occurs, and reptiles for C every time they occur. No cows are reptiles, obviously true. Some animals are not cows. Substituting in animals for P, and substituting in cows for D again. Again, this is clearly and obviously true. And finally, we get our conclusion. Some reptiles are not animals. And again, this is clearly and obviously false. So now we've got a substitution instance, has the same underlying logical structure, the same relationship between the content elements. The premises are clearly and obviously true. The conclusion, clearly and obviously false.